Hello, here is the very last installment of the Math 101 Final Exam Review video solutions. These are for the Chapter 8 problems listed below. Let's go ahead and get started. Now, number 1 is already set up in a perfect square, so we're just going to use square roots. I'm going to go ahead and put that up here. 2x minus 5 and negative 16. So that's square root both sides. Remember when you do square root to put plus or minus right there. So now those are gone. I'm left with 2x minus 5 equals plus or minus. Alright, so now I have negative inside the square root. Right now I'm going to have I in that result. And the square root of 16 is 4. So I have plus or minus 4i. Let's continue to just get x alone. I won't be able to combine it with the 4i, but I can put them all on the same side. So I'm going to add 5 to both sides. So I have 2x equals 5 plus or minus 4i, and let's divide by 2. So you can leave your answer like that, or you can give them both a 2. So you have 5 halves plus or minus 4 divided by 2 is 2i. And you can write it either way. The plus sign was a little messy. Plus or minus 2i there at the end. Alright, number 2, we're going to solve this one. You can complete the square. Let's practice using the quadratic formula because number 3 we're going to complete the square on. So a is 5, b is 15, and c is negative 1. Let's write the quadratic formula for reference. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a at the bottom. So b is 15, so we got negative 15 plus or minus the square root. Ooh, square root, that's a big square root. 15 squared is 225. You can go ahead and write that. Minus 4 times a, which is 5, and c is negative 1 all over 2 times 5, which was a. Now from here we're just simplifying. Negative 15 plus or minus square root of 225, and then that 4 and negative 1 and 5 become plus 20 over 10. So I'm at negative 15 plus or minus the square root of 245 all over 10. Last thing we want to do is see if that 245 simplifies at all. And it turns out that is actually 49 times 5. If we split up those square roots, it becomes negative 15 plus or minus square root of 49 is 7, root 5 over 10. Just like on number 1, you can leave it that way, or you can give them each their own 10 and simplify from there, or you can just leave it like that. Alright, number 3 says to solve by completing the square. So let's get that set up. I'm going to leave my C open right there. Just going to put a gap right there. And I have 13. I'm going to add something on that side. Now to figure out completing the square, we always take the middle term and divide it by 2. Minus 5 halves squared. We know that that's going to be in our parentheses, but in order to get there, we're going to need to add that 5 halves squared on top. So add negative 5 halves squared right there. And that already factors to be x minus 5 halves, or 2.5 squared. But we need to simplify the other side. So this is 13 plus 5 times 5 is 25. 2 times 2 is 4. And if we get those to have the common denominator, it all equals out to be 77 over 4. You can check that on your own, or do you use your calculator. And then just like on number 1, we're ready to square root. So I'll put my plus or minus so I don't forget it. Square root that. And I have x minus 5 halves equals, whoops, yeah, plus or minus. Again, I'm going to split up the square root, so I have a square root of the numerator. And the square root of the denominator is 2. Square root of 4 is 2. Let's get x alone. Let me scroll down a little bit. X equals 5 halves plus or minus the square root of 77 over 2. And if you want, of course, you can always put that over the same 2 since they already match. Or you can put that in your calculator to get 2 decimal answers. That would work too. Alright, number 4 has a little bit of numbers, chapter 6 and chapter 8. But we can use our chapter 8 skills to solve it. But first, let's start off, just like we did in chapter 6, with getting a common denominator. So let's write that down. So I have a denominator of 4, and a denominator of y plus 2, and a denominator of y. So that's what I'm going to end up multiplying by to get these to cancel. So I have 4, let's go and write it 3 times and see what cancels. 4y, y plus 2. Alright, on the first one, just the 4's cancel, and we have 1y times y plus 2, and we've got y squared plus 2y when we distribute that y in. On the second one, we have the y plus 2 cancels, and we have 6 times 4y, which is 24y. And then on this last one, on the right-hand side of the equals, just 1y is canceling, so we're going to have 6 times 4 is 24 again, y plus 2. Let's go ahead and distribute and combine things. So I've got y squared plus 26y here, and 24y plus 24 times 2 is 48. Because this is now a quadratic, we're going to just move everything over and use that quadratic formula. That is so useful. Could try to factor it, but I don't think this one's going to factor nicely for us, sadly. So y squared plus 2y. Actually, it does factor. So we can factor it, we can use the quadratic formula. Let's go ahead and factor it just to review that a little bit. So I need to multiply to be negative 4 to get out to be 2. So that's going to be y plus 8, y minus 6 equals 0. Set those equal to 0, and I get y equals negative 8, and y equals positive 6. Remember, with rational expressions, you always want to check to make sure that none of them gives you a 0 in the denominator. If I plug in negative 8 back at the beginning, that would still be good, and so would 6. So both of these are correct. Awesome. All right, number 5, we got lots to do on number 5. We got to find the vertex, intercepts, and graph it. So let's start with that. Let me write it down over here so I don't lose it. Okay, I'm just going to scroll down. So I have enough room to graph it. X squared plus 2x minus 1. All right, let's start with the vertex. We have a handy formula for the vertex that gives us the x coordinate, which is negative b over 2a. B is 2, so that's negative 2. A is negative 1, and so negative 2 over negative 2 is just positive 1. Now to find the y coordinate, we're going to plug in 1 wherever we see it. So that's negative 1, because 1 squared and then the negative out front, plus 2 minus 1. If you add those together, you get 0. So the vertex is at the point 1, 0. Now because it has a 0 in the y, that is actually both the vertex and the x-intercept. It's on the x-axis. And so we don't need to find the x-intercepts anymore. So there's only one of them, and it's the vertex. So let's go ahead and find the y-intercept. That's a little bit easier anyway. We're going to plug in 0 for x and see what the y value is. So we're going to plug that in. G of 0 is negative 0 squared plus 2 times 0 minus 1. So that first part's just gone. And our y-intercept is 0, negative 1. Let's label that. Now this is only 2 points, and you need a few more than that to graph an equation for a parabola, right? 2 points is plenty for a line, but this is a parabola. So I'm just going to plug in another point. Let's do, what if x equals 2, right? Pick, plug, plot this. So g of 2 is negative 2 squared plus 2 times 2 minus 1. So I get negative 4 plus 4 minus 1. So my other point is 2, negative 1. Let's go ahead and graph this. Our vertex, remember, is either the highest or the lowest point on the graph, and so it's going to be at, we said, 1, 0. So that's right here. And that's also the x-intercept, so it's on the x-axis. Then we have our y-intercept of 0, negative 1. Again, if we were graphing a line, we could just connect the dots and be done. But it's a parabola, so we need a few more parts to it. So I'm going to do 2, negative 1. If you wanted to plug in more numbers, you plug in 3 or negative 1. We already have our general shape of a parabola just with 3 points. So there you go. That is the last one for chapter 8. And that's the last of our video solutions for the final exam review. Good luck on your final.